Today we are going to talk about Daniell cell or Galvanic cell. It is also known as Voltaic cell as well. But before addressing these electrochemical cells, we must have simple idea about oxidation and reduction. Oxidation is the loss of electron, where reduction is gain of electron. Oxidation takes place at anode and reduction takes place at cathode. Usually we have two different type of electrodes. These are electrodes. Electrode is a metal plate where oxidation and reduction take place. So oxidation is the loss of electron and reduction is the gain of electron. In galvanic cell, usually chemical energy is converted into electrical energy, and this process is spontaneous. In other words, this interconversion takes place without the assistance of external force. And ordinarily, a galvanic cell can be represented as it consists of two electrodes. One is zinc, which act as an anode, or in other words, here oxidations take place. And another is the copper electrode that act as a cathode, where a reduction process takes place. In other words, zinc electrode loses electron that move from zinc toward copper electrode. Here we can mathematically represent the equation as zinc as a cathode. It oxidizes for giving Zn plus 2. It loses 2 electrons, and these 2 electrons are gained by copper plus 2 by reducing it to metallic copper. As a whole, the net reaction is net cell reaction is which is a type of redox reaction. So it is this redox process that generates an electricity in galvanic cell. Basically, zinc electrode is dipped in 1 molar HCl solution, or its respective Zn4 solution, and copper electrode is dipped in its respective solutions such as copper sulfate. Both are 1 molar in concentration. As far as once the chemical process takes place, then the zinc electrode loses its size. Now, why? Because zinc ion from the metal drifts into the solution after losing 2 electrons. So, in other words, we can say that these compartments gets rich in cation or Zn plus 2 ion. We have already ZnSO4 solution here that ionize that Zn plus 2 plus SO4 2 minus. As far as anode or cathode compartment is concerned, here we have CuSO4 solution that ionize into Cu2 plus SO4. here few ions from solution are reduced on the surface of cathode. In other words, the size of cathode is increased once the cell reaction began to operate. Here, the positive charge is reduced, or there is reduction of positive charge. In order to balance this buildup of positive charge in anode compartment and decline of positive charge in cathode compartment, we connect both the solution through a salt bridge, which is usually filled with an electrolyte such as KCl. It can be ammonium hydroxide or any electrolytic medium in order to maintain the balance of both compartment. If the two solutions are not connected by a salt bridge, then there will be a buildup of positive charge in anode compartment and a buildup of negative charge in cathode compartment that will ultimately halt the operation of the cell. So in order to avoid this danger, we usually connect both the compartment via salt bridge. So this is a simple demonstration of galvanic cell in which the transformation of the zinc anode loses electron that passes through a wire and move toward cathode. And this movement of electron ultimately generate electricity. So here we can check out how a chemical change help in production of electricity. So this is all about galvanic cell. If the two cells are not connected via salt bridge, then the buildup of cation and anode and cathode compartment respectively will prevent the cell from operating. So the net cell reaction can be write out as is 1 molar here. The two parallel lines represent salt bridge. Anode cell is written first, followed by a cathode cell. So here we can see that the zinc ion zinc anode is oxidized to zinc ion, which is 1 molar. Both the solution are 1 molar in concentration.